Hi everyone and welcome back. This video is a continuation of a previous video where we began working with some of the basics of the Swift programming language. We talked about variables and specifically how we can have variable variables or constant variables, how we can print out values of variables, how Swift can infer the types of variables if we don't explicitly declare the type. And then we did a little exercise where we began exploring the different members that are associated with an object. So for example, here we had two strings and we saw that there is a property member of the string type called count, which will tell us the number of characters in the string. In this video, we're going to continue on with some basics of Swift, talking about arrays, random numbers, conditionals, and loops. So let's go ahead and start a new section here using our mark comment called arrays. So an array is a sequence of objects, right? In Swift, like many other programming languages like Java and C++, all of the elements in the array must be of the same type. And once you specify the type of the elements of an array in Swift, you cannot change that type. So let's do an example where we'll have an array of strings. And just for fun, let's do an array of strings that represent food items. So I'm going to have a variable called food, which I'm going to initialize to these three strings: eggs, bacon, and bagels. So let's note a few things about what I've done here. First off, I've initialized my array at the same time I've declared it, using the hard bracket notation and comma separating elements. I've also let Swift infer the type of the elements in this array. So Swift is going to infer that the type of this is array of string. Okay, this is the type of my array. It is an array as noted by these hard brackets, and each element in the array is a string. All right, let's print out this array and see its contents. There it is. We've got zero base indexing with Swift arrays. So if I want to print out eggs, that would be food sub 0. We've also got a lot of really nice members on the string type, including some properties like count, which just like we saw with the string type will tell us how many elements there are in the array. So let's print out food.count. And while we're at it, let's try another one. Food.isEmpty. This will return a bool if the array is empty or not. So we've got three items in this array. That makes sense. And food.isEmpty is false. That makes sense as well. There are three items, so this array is not empty. All right, something that's nice about Swift arrays, very similar to Java array lists or Python lists or C++ vectors, is that arrays can grow and shrink in size. So let's say we want to add another item. We can add an item via the append instance method. So food.append, and you can see that I can append a new string element or the contents of another sequence. Well, let's just append another string element and let's add coffee, sticking with our breakfast theme here. And we'll see that we now have four items or four elements in our array. So anytime you want to explore the different members of a type, such as the instance methods or the class level methods or the properties of the type, you can simply take your type or an object of that type, like food is an object of type array, and press dot, and you'll be able to kind of see this nice little overlay of all of the different available members for you to choose from. So I've got a little challenge for you to try here. Call this task 2. Try removing the first element. See if you can explore a little bit in Xcode and figure out how to remove the first element, which is eggs. Print out your array after you've removed eggs and confirm that it's gone. All right, let's try this. So I'm going to type food and then press dot, and I'm going to start typing what I hope or what I think is going to be available for me to use as a variable, i.e. a property, or a method, i.e. a class level method or an instance level method. So I'm going to type remove, and you'll see that there are actually two different remove related methods I can use. So remove at, where I'm going to provide an integer index, or remove all, which will essentially clear out our entire list. So let's do remove at, and I'm going to type in 0 for my index. Now, note that in this method call here, you do actually have to have the at colon. This is the external parameter name for this parameter integer index. So you do have to have this here or it won't compile. In another video, we're going to talk about functions in Swift, and we'll go through all of the details related to what external and internal parameter names are. All right, so after calling food.remove at, we'll see that eggs is gone, and now our new first element is bacon. All right, so far so good. Let's move on to our next section. Now we're going to work with random numbers. This will be a short section, but an important one, because a lot of applications, whether they're macOS command line projects or iOS projects, need some degree of randomness to them, especially if you're working with things like games. So let's do a little example here where, let's say we want to throw a 6-sided die and save it in a variable called random. All right, so we'll have a variable called random, and this is going to be assigned the return value of a call to a function that will randomly generate a number between 0 and a given upper bound. So that function is kind of long, but it's this one here. If you start typing arc, A-R-C, and then the number 4, random, you're going to see arc for random uniform. This is the function we want. So this function accepts a single argument, which you can see the parameter name for it is upper bound. It's of type uint32 or an unsigned 32-bit integer. You can see that it also returns a uint32. So I do want this function, so I'm going to press enter. And for my upper bound, I'm going to simply type 6. Okay, note that the 6 is not included. So this is going to give me a random number that's either 0, 1, 2, 3, 4, or 5. So to fix this to the range I want, which is a 6-sided die, 1, 2, 3, 4, 5, 6, I'm going to simply add 1. I'm going to print out my random number, and we should see 1, 2, 3, 4, 5, or 6. Let me run it again. I got 6, 6, 3, and I'll just run one more time. 4. Awesome. Well, remember I said that the return value of this function is a uint32? Let's confirm that that's the case. If you option click on any identifier inside of a Swift file, it's going to show you a quick documentation kind of hover dialog where you can read some information about that identifier or that type. So let's option and then click on random, and we'll see that random is declared as a uint32. Well, I didn't actually specify the type of random to be uint32, but Swift can infer it because this function, arc for random uniform, is going to return a uint32. Now, that's not such a big deal, but if you're working with a type or some kind of operator that requires an int specifically, not a uint32, then it's good to know how you can typecast between different types in Swift. Recall that I said that every type in Swift is an object and there are no primitives. Well, this is actually really handy because that means that all types, even types, simple types like ints or doubles, have initializers, which if you're coming from like a Java or a C++ background, these are your constructors, okay? You can invoke an initializer for a type like int, and it's probably overloaded to accept whatever type you want to convert from. So for example, let's declare another variable here. I'll call it random as int, and I'm going to assign it the return value of invoking the initializer for the int type, where I'm going to pass in a uint32. And you can see that the int initializer is overloaded to accept so many different argument types. So many. So let's just pass in our random, which is a uint32, and I'll run this. I'm not printing it out, so I won't see it. But now I'll be able to option click on random as int and see I have an integer version of my random die roll, whereas with random, I had a uint32 version. Okay, so this is just something really handy to keep in mind. In order to typecast, you can invoke the initializer for that type you want to convert to. All right, we are cruising right along. Next Swift basic to cover is conditionals. Okay, conditionals are your if statements and your switch statements. So if statements in Swift are very, very, very similar to kind of the C style, like C++ or Java, if, else structure. So let me just do a really simple example here. Let's have a variable x. Let's initialize it to 100. And then we're going to have an if statement. Notice this is the standard if keyword, just like the C style. And I can have parentheses around my Boolean condition if I want, but I don't have to. So I could do x greater than 90, and then curly brackets in order to create a block associated with this Boolean condition. And I could come back and put parens around here if I wanted to. This is totally optional. So let's say if x is greater than 90, we'll simply just print out x is greater than 90. Not too creative here, but a demo of an if statement nevertheless. Okay, I could add an else if here if I wanted. I could add just an else, or I can just leave my if statement as is. There are also switch statements in Swift. I'm not going to cover them right now. I'll cover them when we cover enumerated types or enums because they go hand in hand. All right, that's really all there is for conditionals at this point. Pretty straightforward, very similar to your Java or C++ background. All right, the next area we're going to cover are loops or iterative statements. Loops in Swift are a little bit different, but they're very fun. So you're probably used to the C style for loops. Well, we don't actually have a C style for loop in Swift. So if you're a little unsure about what I'm talking about, this would be something like for int I is assigned 0, I less than, say, 10, I plus plus, something like this. So this does not exist in Swift. Instead, we have something called a for in loop, which from my background in Python, I call this a for each loop. So I may say that, but really it's called a for in loop. So let me show you the syntax for a for in loop. So we'll have a loop control variable I, for I in. Okay, so there you see the for in part of the for in loop. For I in, and then we specify a range or a sequence. So let's say we want to rewrite this traditional C style for loop. So we're going to run from 0 inclusive to 10 exclusive. Then we would write 0 dot dot less than 10. So this is effectively the same for loop as this for loop right here. Let's just simply print out I. And because I'm going to want all of these numbers on the same line, because I don't have a lot of space down here with my font so big in Xcode, I'm going to show you how you can specify that there isn't going to be a new line character appended to the end of a print statement, or how you can specify a custom terminator or a custom string appended to the end of a print statement. So I'll just write terminator, and then I'm going to assign that to be the empty string. So all of these numbers are going to be jammed together. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just to reiterate, terminator here is going to specify that instead of a new line character appended at the end of this print statement, which is the default, I want the empty string appended, which is going to kind of butt all these numbers right up next to each other. If I did a comma space, then they would all be comma separated, but we would get an extra comma at the end. So I'll just throw in a print statement here in order to kind of reset my output to be on the next line. All right, a few other things to note about the for in loop. So first off, if you want to do a closed range, you can do 0 dot dot dot, so 3 dots instead of 2 dots and a less than sign, and then your ending value of your range, and this will be inclusive. Another interesting thing to note about Swift is you have to have equal white space on both sides of an operator. So for example, let's say I put a space here and I try and run this. I'm gonna get an error. Let's say, for example, with x is assigned 100, I delete one of the spaces here. I'm gonna get an error, build failed, okay? So these are just things to keep in mind, that when I'm typing some white space, it's not by choice. It's actually required as part of the Swift programming language. In your intro to programming classes, you may have had a coding standard. Well, that coding standard was preparing you for this day, right? Like in my intro classes, I have a coding standard that does specify you should be consistent in your white space use, right? So a space on both sides of your assignment operator or a space on neither side. This will compile in Swift, but this will not compile in Swift. All right, so just some things to keep in mind, okay? This syntax here should match exactly. All right, there are 2 other loops that we have in Swift, and I'd like to cover those now. So the first one is a while loop, and I'm not going to do a demo of this because this is very similar to the C-style while loops. And then the second one is called a repeat while, which is similar to C-style do while loop. So I'm not going to do a demo of this either. It's the exact same, except you use the word or the keyword repeat instead of do, and you have your Boolean condition associated with your while loop at the bottom of your block, So repeat whiles, like do whiles, their bodies always execute at least once. All right, so let me give you a task to try this out. Solve this simple problem using each of the 3 loops, okay? So remember, we've got a for in loop, while loop, and a repeat while loop. So I want you to solve the same problem 3 times. And here's the problem. Print the first 20 even numbers separated by spaces. So for example, that would be 2, 4, 6, all the way up to 40. Okay, pause the video and try this out. First 20 even numbers solved 3 different ways: for in, while, and repeat while. All right, I'm gonna do this now. I'll do it with a while loop since I haven't done a while loop example yet. So I've already got a variable called x that I declared up here on line 63. So I'm gonna set x to 2, and while x is less than or equal to 40, I'm going to repeat all of the code between these curly brackets, the body of my while loop. Well, I'm going to print out x, but remember, I want them to be separated by spaces. All of my numbers separated by spaces. So I'm going to use that terminator parameter again and specify that these should be separated by spaces. Don't forget your progress towards your Boolean condition being false. X plus assign, compound operator here, 2. And then at the end, I'm going to simply have a print statement in order to get a new line. All right, here are my first 20 even numbers. All right, now let's solve this again using a repeat while. So I'm going to initialize x to 2 again. And instead of writing repeat, I'm going to write, now I'm going to solve this problem again using a repeat while. So I'm going to initialize x to 2 and repeat all of this code that I had from my while loop while x is less than or equal to 40. And I should get the exact same output here, and I do. All right, let's just do the for in loop for fun. So I'm going to have for I in, and I'm going to do 1 dot dot dot, 3 dots, so I'm inclusive of my endpoint, 20. And I'm simply going to print out I times 2 and then have my terminator be a space. And there I have the exact same output. All right, well, that is it for this installment of Swift Basics Fun. We covered a lot of topics: arrays, random numbers, conditionals, and loops. In the upcoming videos, we're going to cover 2 more very important topics related to the basics of Swift, and that includes optionals and functions. Thanks for watching.